Hey students, this is lesson 6.2, properties of parallelograms. In this lesson, you will learn to use relationships among sides and angles of parallelograms and to use relationships among diagonals of parallelograms. Quick review here. Supplementary angles are two angles whose measures sum to 180. Suppose x and y are supplementary. If the measure of angle x equals 75, then the measure of angle y equals 105. A linear pair is supplementary. Angle AFB and angle EFD at the right are supplementary. And the word consecutive we're going to use in this lesson, so you should know what that means. Consecutive sides, consecutive angles in the diagram would be like A and B are consecutive, or A and F are consecutive. So angle A is a consecutive angle to angle B, or angle F. C and D are consecutive, D and E are consecutive. I think I can skip the next thing. All right, here's our theorems. And I think we should make a habit in here of trying to explain the theorem rather than using theorem 6.3. So theorem 6.3, if the quadrilateral is a parallelogram, then its opposite sides are congruent. So we might say something like opposite sides are congruent in parallelograms. Quadrilateral is a parallelogram, then its consecutive angles are supplementary. So we might say parallelograms have supplementary consecutive angles. If a quadrilateral is a parallelogram, then its opposite angles are congruent. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So AE would be congruent to BC because AC is a bisector of BD. I can mark it like that. Those are congruent. BE is congruent to BB. So something like that. Okay, so using consecutive angles. Now remember, according to what we just read in a parallelogram, consecutive angles are supplementary. So if this is a parallelogram, and this symbol is an indication that it's a parallelogram. So if S is 71, we're trying to find R. We know that the measure of angle R plus the measure of angle S is equal to 180, and that's because parallelograms have supplementary consecutive angles. And we know S is 71, so we can substitute that in. And we can subtract 71 from 180, and we get the measure of angle R is equal to 109. Okay. Go ahead and do the next problem. I'll put the answers up for you. All right, we're going to use properties of parallelograms and a proof here. What we want to prove is that the angle M is congruent to angle E. So this one and this one are congruent. And we're going to use the given that these are parallelograms to help us do that. So let's write the given. A, B, C, D, and N, M, L, B are parallelograms. That's given. And because of that, we can say that angle B is congruent to angle M, and angle B is congruent to angle B. And that's because parallelograms have congruent opposite angles. And then using the transitive property of congruence, we can say that angle M is congruent to angle B, Alright, go ahead, you try it. Try this group and check back for the answers. All right, we're going to use the properties of parallelograms to solve for some values A and B in this. Now, the property that we're going to use is that parallelograms have bisecting diagonals. And knowing that, that means that these two segments are congruent and these two segments are congruent. So that produces a system of equations. We get b is equal to a plus 2, and we get a is equal to 2b minus 8. And that's because parallelograms have bisecting diagonals. So let's do substitution here next. And if b is equal to a plus 2 and a is equal to 2b minus 8, and we're actually, we're trying to find both values, so let's just figure a way we can substitute here. I'm going to use the first equation, but instead of this a, I'm going to put 2b minus 8 plus 2. So I'll just highlight here where I made my substitution. I put what a is equal to where a was in the original equation. So now I'm just going to simplify that, and I get b is equal to 2b minus 6. And if I use the subtraction or the addition property of equality, so I'm going to add 6 to both sides and subtract b from both sides, or add negative b to both sides, and I get 6 is equal to b. Okay. Now I need to find my two values. Hj is equal to 2a, 2 times a, because a goes to here, so the whole, since those are bisecting segments, I can just say it's equal to 2a, and a, I don't have the value of a yet, so I should find that. From this equation right here, I know that a is equal to 2 times b minus 8, and I just found out that b is 6, so I can just do 2 times 6 minus 8, which is 12 minus 8, which is 4. So I'm going to substitute 4 for a, and I'm going to get hj is equal to 8. And then ik is equal to 2 times b. Ik is, again, a bisected segment, and b is 6, so I can just substitute that, and I get 12. So hj is 8, and ik is 12. Go ahead and try the next problem. Check back for the answer. I'll run through this problem with you. So this is an equation that we get by substituting values in that'll help me find x. So if I simplify this, I get 3x plus 3 minus 7 equals 2x. And that simplifies to 3x minus 4 equals 2x. Subtracting 3x from both sides gives me negative 4 equals negative 1x. Dividing both sides by negative 1 gives me x equals 4. Okay, and I also know that y is equal to x plus 1 from this. And so y is equal to 4 plus 1, substituting the value of x I just found, so y is equal to 5. And now I can find my values, pt and st and pr and sq. You can check back for the answer. All right, a related theorem here has to do with parallel lines and transversals. If you cut off equal segments of a transversal, like right here, and the lines are parallel, then any other transversal cutting across those parallel lines will have congruent segments also. So I'm just going to label it like this. Those two would also be congruent. So we would put DF here. And so if I want to use that idea here, in this figure below, you have this is parallel to this, and that's parallel to that. So all three lines are really parallel. And if RS equals ST equals 5, so those are 5 right there. And we know that WV is 7. And we want to find WU. We know that WV is equal to VU, and that's equal to 7. Both of them are 7, so we can say that's 7. And we also know that WV is equal to, or WU is equal to WV plus VU, and that's the segment addition postulate. And by substitution, we get WU is equal to 7, which is 14 simplified. Go ahead, try problem number 4. So we can use that transversal idea. All right, then the lesson check. Place a check by the box if you are given information. So QB is 10. Explain why this statement might not be correct. That QB equals 10. And we know that we have 3 lines cut by 2 transversals. 3 lines parallel cut by 2 transversals. There's no indication on this diagram that those 3 lines are parallel. We would need this given. So we can't really say that. So we're going to not put a check there. Put a check there. What needs to be true for QB to equal 10? We would need PQ is parallel to RS is parallel to QB. And so the classmate statement is not correct, may not be correct, because parallel lines are not given. All right, that's the lesson. See you in class.